Okay, so in this video I just want to continue to practice making conversions. We did a lot of degrees to radians and they were all the special angles, but what about things that are not so special, right? How do I convert those? Well, again, when we're going from here everything is in degrees, I know we are in degrees because of the little degree symbol. So we're going to be converting to radians, and what we just learned is that 1 degree is equivalent to 1 over 80 pi radians. So essentially the idea is to take our degree measure and multiply it by pi over 180, and we saw that on steroids. So just doing it again, I'm going to multiply this by pi over 180, right? This becomes 75 pi over 180, and then it becomes basically a reduction. I think you can begin with maybe 5. 5 will go into there, let's see, 15 times. And 5 will go into there 36 times, okay? And then if we take a look what's left, I think 3 goes into there 5 times and there 12 times. So we're looking at 5 pi over 12, all right? So 75 degrees converts to 5 pi over 12 radians. Alrighty, so it just really becomes the first part's easy, just multiply by pi over 180. The next part is actually reducing our fractions and going along. So 100 degrees, again, this starts by multiplying by our conversion factor, pi over 180. So we have 100 pi over 180. I see that 10 goes into this, and then how about we use 2, right? 2 goes into there 5 times, and 2 goes into there 9 times. So we're talking about 5 pi over 9, all right, as our radian measure. So 100 degrees is 5 pi over 9 radians. And again, remember, these are radius lengths. If we were to break out our calculators and get an estimate, we're measuring how many radius lengths are along the edge. Negative 160, again, don't let the negative throw you off. Negative radian measures mean the same thing. We're just going clockwise as opposed to counterclockwise. So the conversion factor is the same. We're just going to have a negative in front of it. So we have negative 160 pi over 180. Again, the zeros definitely cancel out. And again, let's go by 2. I think 2 goes into there 8 times and there 9 times. So we're talking about negative 8 pi over 9, right, as our corresponding radian measure with regard to negative 160 degrees. Okay. For the next one, again, we have a negative, no problem, but we also have a decimal. And so what I'd encourage you to do, since this is all a bunch of fraction work anyways, right, why don't we rewrite, right, this is 15 3/4, which is basically 63 over 4. And so what we're basically doing is taking negative 63 over 4 degrees and we're multiplying it to pi over 180. This way we get the most accurate answer that we can, rather than converting things to decimals where we can lose some accuracy. Let me make sure I just did that right. Yeah, 4 into 60 goes in 50. Yeah, all right. And so when we put this together, we're talking about negative 63 pi over 4 times 180. And I believe the factor that's common is 9. 9 actually goes into there 20 times, and 9 goes in there 7 times. So we have negative 7 pi, and then 4 times 20 is 80. So there would be a nice, accurate radian measure handling your degree, all right, your decimal degree. So I say convert your decimal degree to its improper fraction form, and then just multiply by our thing, and you're just basically working with fractions. Last but not least, pi degrees. Well, again, just because there's a pi doesn't mean we're talking radians, right? That degree symbol means we're talking about 3.14. So how do I convert it to radian measure? Well, that would be pi times pi over 180. Of course, that's over 1, so we're talking about pi squared over 180. And so there would be the number of radians, right? It's very, very small, right? Because this is almost 3 squared. We're talking 9 divided by 180. So again, very, very, very tiny fractional part of a radius being swept out. with regard to that. So there's how you can convert. We're still using the same conversion factor, and it really just becomes an exercise in simplifying fractions, if you would. Okay, so let me break away. We're going to go the other way, right? We're going to. You'll notice in this next round there is no degree symbol, even in here and here. So how do we convert these radian measures down here to their degree mode? But let's cut away to another video for that.